This short video is to demonstrate some zonal statistics, a new skill that you'll be learning in this lab. We're going to navigate to Arc Toolbox, Spatial Analyst Tools, Zonal, and Zonal Statistics. We get a new window. The zones that we're using are the school grounds, and Zonal Statistics will calculate the statistics for us, mean, medium, sum, standard deviation, etc., for a particular zone, and an output a new raster in which the values of the cells for each zone correspond to the statistics that we choose. For example, we're going to be calculating the mean imperviousness for the school grounds. Remember to click the Show Help to get information on the help, and then also click on Tool Help to get more information on the zonal statistics. I have also provided a PDF of this information. For now, I will close these zonal statistics and get on with our analysis. In this case, I'm going to choose School Grounds LM for elementary. And then I must choose a zone field from that field. Or excuse me, a zone field from that shapefile. The zones that we are creating are defined by the grounds of the school. Therefore, each zone will correspond to an individual school. We can choose any field name that contains a unique value for each school and is populated for each school. I suggest using name. So I'm going to, name is already selected, so I'll just stick with name. We must now choose an input raster, and we'll choose Pierce Impervious Final because that's the raster that we should use. This is the raster data set that will be used to calculate the statistics for each zone, such as the mean percent of impervious surface for each school. I'll now use the Browse button to export the output raster into my geodatabase, which is the Lab 3 geodatabase. I'll call the new raster Pierce Impervious Schools. It's in the geodatabase, therefore I just need to type Pierce Impervious Schools and click Save. Mean is already selected, and I'm going to choose that. Leave this checked as well. Ignore no data in calculations, and then we'll click OK. As this runs, it seems to be very quick. Oh, it's building a string lookup. When this runs, when it gets done, Pierce Impervious Schools will be added to the map as a new layer. That analysis took about 1.5 minutes. Close that and proceed. Pierce Impervious Schools is added to the map, and by default, of course, it's in a stretched format or view. I'm going to move it to the top and then open the symbology for it and make some modifications. We're going to start by changing it from stretched to classified underneath this show area. Then we're going to click the Classify button to open up the classification dialog. At this point, you should be determining your mean percent of impervious surface for elementary schools in Pierce County. You should also record your standard deviation. point of note, if you're working with others next to each other or comparing notes to make sure you're both on track, don't be alarmed if these are a little bit different for each of you. Again, don't be alarmed if they're a little bit different for each of you. And we'll talk about that in class. I'm going to change the classification method up above to standard deviation using the drop-down menu, and I'm going to leave the interval set to 1 standard deviation, which is right here. Using this classification method, we can emphasize the schools that have the highest percentages of impervious surface without regard for the number of schools in each classification category. Again, if you're working with others, you may find that the number of classes may slightly vary. I'm going to click OK to exit the classification dialog. And here I'm going to select a green to red color ramp. Scrolling down, green to red, and then click OK once more so that I can symbolize the schools. At this time, even though we did a lot of nice handiwork, I'm going to turn off Pierce Impervious Schools because we're going to be recreating a similar layer using vector data in the next steps. The reason being, in order to interact with the Pierce Impervious Schools data using vector tools, we need to convert this vector, or raster, we need to convert it to a vector from a raster. And this is actually going to be a point data set. And I'm going to take you through those steps right now. We're going to go to the Arc Toolbox Conversion Tools, which are up higher. Conversion Tools from raster to point. And we get the dialog box. We're going to choose Pierce Impervious Schools from the Input Raster drop-down menu. Value will be added by default as your field because that's the only choice. We're going to browse to our Pierce Schools Analysis Feature Dataset, which is our standard feature dataset for Lab 3. Double-click on it. And we're going to name this new layer or feature class Pierce Schools _ points. That will remind us that they are points. Before you click Save, make a note of item, right now it's on page 15, number 7.14, that tells you that you may receive an error message after running the raster to point procedure, and the Pierce Schools Points feature may not be added automatically to your table or table of contents. But check your feature dataset because Pierce Schools Points most likely has been added to it. And then it can easily be added to your map for analysis in the next few steps. So let's click Save and see what happens. We'll see if I get an error. And now I'm going to click OK. It's starting to run. I'm going to pause while it runs. It may be important to note that I do not click this button, close this dialog when completed successfully. And here we do have an error. No features found in blah 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 blah. Possible empty feature class failed to execute raster to point. It only took 16 seconds to come up with this error. I'm going to click Close. The dialog opened again. I'm going to minimize it and go to Arc Catalog and look at the feature dataset, and Pierce Schools Points is included. I'm going to take that and drag it over to my layers, or under the word layers in my table of contents. And if I turn it on and off, I should be able to see it. Let me turn off these schools. We'll have to investigate to see if this worked. This is interesting. If I zoom to my layer, Pierce Schools Points, I get a very tiny dot. As I zoom in, I see that there's my Pierce County. If I zoom to this layer, I get the data. If I zoom in too far, it seems to disappear. As I scroll backwards, it's very interesting why this isn't showing. I could look at the properties and symbology, symbol levels. You can play around with that to see why it isn't showing, but we'll continue and assume that it is correct. Click OK. Let's look at the attribute table. The grounds of each school are comprised of a series of points, each of which includes a value and a grid code field. Here's the grid code field. If I sort descending, notice some of them go to 80. And you can scroll through there to see it goes from 0 to about 80. The value in grid code is the mean % impervious surface for the school grounds that intersect with this set of points. In the next step, we'll use a spatial join to add the grid code field to our school grounds elementary feature class. By converting this raster to points, we've made it possible to conduct a spatial join between the Pierce Schools points layer and the school grounds elementary layer. From here, let's just close this, and we're going to open the Spatial Join tool, which is found in Analysis Tools, Overlay, Spatial Join. And we get the Spatial Join box. We're going to choose School Grounds LM for the target features. Our join features are the points that we created in the Pierce Schools points. We're going to save the output feature in our feature dataset and name it School Grounds LM2. I click this output feature class and wait. School Grounds LM2 and click Save. The join operation must be join 1-to-1, which we have. We will keep all target features checked as it is. In the field map, scroll down until you find the grid code field. Here is the grid code at the very bottom. And click Rename. Here I have getting ready to rename, and on rename we're going to rename it PCT, which stands for percent, IMP, which stands for impervious, SURFACE, percent impervious surface. We're going to use the intersect match method. I'm going to click out into this white space to get that to take, and then click OK, and we're hoping that the earlier errors will not prevent this feature from being added to the map. This is running. I'm going to pause while it runs. Notice executing Spatial Join, and do not click this button. We want to see what happens in here. The process has concluded in 15 seconds. I click Close. And School Grounds LM2 has been added to my map. I'm going to open that, or open the attribute table, and each entry now includes a value in the percent impervious surface field, which will be supposedly at the end. Since that does not show up, I've looked very carefully. I'm going to give it another shot by going back and trying it again. I'm going to go to the Spatial Join tool and choose my school grounds LM. The join features are the points that I created in Pierce School's points. I'm going to save it as School Grounds LM2, but in this case, since I already have or created a 2, but it was incorrect, I'm going to change it to LM3 by just clicking the one with 2 and changing it to a 3. Feature classes is of course correct because we're going to the data set. I click Save. We'll keep the join 1-to-1, keep all target features, and again it's time to name the grid code float. I'm going to right click and rename again, and this time use a shorter field name, PCTIMPSURF, and then click out of it. Now it should come out in my final attribute table. It would be good to get the tool help, in this case Spatial Join Analysis. I'm going to copy and then paste this into the desktop 10 help so that I can create a PDF for you to read. I'm going to pause as I read through this. You can look at the PDF that I provided. The Spatial Join is now added to your list of documents in week 2. And we'll give this another shot. Oh, let's see if there's anything below intersect. No, we will not have a search radius. Let's go. And we'll pause while it completes. It looks like it took 16 seconds. Let's close and look at the attribute table. We have a join count. Cautiously scrolling to the right, and there is no field. Here I am, back what seems like instantaneously to you, but I've just spent 20 minutes researching and creating a LM4 to figure out why this isn't working. And what I've realized is, if I open the attribute table, there is a field called grid code. And if you remember from the directions, we changed the name of grid code. So I'm wondering if I go to show field aliases and turn that off, if that would change anything, and it does not. So I'll go back and show field alias. Turn all fields on. Let's see if that changes anything. It does not. For some reason, the grid code is not coming through as what we changed it to, which would be percent impervious surface. Why that is, I cannot yet determine, but we do know now that our number 2 came through properly. I'm going to look at number 2 with you. Open attribute table. Grid code right there. Now we're going to go with the grid code that came through and worry about why it didn't get renamed later. We are going to do a quick fix. I'm going to add a field and call it percent impervious surface, because that's what we were supposed to call it. It'll be a float because that's what this field type is. I'm going to say OK. Is invalid is a duplicate of an existing field name. This is very interesting. We are having definite issues because it's saying that it already exists. I'm going to say yes. We'll name it % impervious surface 1. And then we're going to do a field calculator, and it is going to equal we'll say grid code. Where is grid code? See, grid code isn't showing up. So there is some sort of issue. It's saying grid code here, but Arc thinks it's % impervious surface because of the order. I'm just going to copy it so that it's % impervious surface. Say OK. All of these same fields from grid code are going to be % impervious surface, and we'll call it good. Again, I think I just want to check the show field aliases and check that, and now it does come up. Very interesting. So it worked all along, it just didn't appear as though it was working. And thus is GIS. From this point, you should follow along in the directions. You're going to use the same method that we used earlier to classify each school as small, average, or large, and create a new field called impervious rank, or IMP rank, type text, in which you classify each school according to the following metric. Schools with the least impervious surface, approximately the bottom 20%, should be a 1. Schools with the most impervious surface, approximately the top 20%, should be classified with a 3, and all other schools should be classified with a 2. Do this on your own, referring back in the directions for hints if necessary. I'm actually going to take you through this since I had a peculiar instance when running the % impervious surface field. Therefore, I need to come up with a new field, which was already listed for us. It's going to be a text, and it is called impervious rank. It's only going to be very short. I'll say it's 5 characters. Well, we'll make it 10 characters, and it'll appear momentarily. There it is. And the next step is to do our classification. I'm going to, and again, use the % impervious surface. I'm going to close this. From here, I'm going to use the LM2 since it seemed to work. Go to Properties, Categories, or excuse me, Quantities. We're going to use the % impervious surface. I'm going to classify using Quantile, 5 classes, and OK. And now the top 20% are down here, the lower 20% are here, and the average are in the middle. I'm going to make a note of these values. Now I'm going to keep this over here if I can. I cannot. I'm going to say OK. The values come in over here. Now I'm going to open the attribute table, put it over on this side so I can still see my values. Scroll over to impervious rank and select by attributes. In this case, I want to select where impervious rank, not impervious rank, where % impervious surface is less than, and I'm going to use this value right here, 29.43671, and apply. Out of 34, 20% 27 sounds right. I'm going to highlight field calculator, and the bottom 20% with the least impervious surface. So the least impervious surface is the lowest, which I just did, and we are going to classify it with a 1. Okay. The ones are in. I'm going to clear my selection, select by attributes, where percent impervious surface, I should try less than or equal to, now that I think about it. Apply. It's still 27, which is good. Okay, now I'm going to do greater than or equal to, and the number I'm going to use is right here, 5481250. Apply. Try that again. Where percent impervious surface 54 point. That is why it didn't work. I needed a point in there. Now apply. There they are. I apply a 3. Instead of a 1, put in a 3. And OK. This will quickly tabulate. I'm going to select by attributes again. Close this, or delete that. Use the impervious rank. I'm going to add to the current selection where impervious rank equals a 1, because I'm going to add the 1s to the 3s, and apply. It didn't work because I didn't have it in there. Verify. Now it will verify. Apply. Now I have the 1s and the 3s. I switch selection. Come over to the field calculator. Instead of 3, I give it a 2. And OK. Now that that's done, I click on there. I'll close this. And the question here, right now it is listed as number 718. What range of values are included in each impervious surface classification category 1, 2, and 3? You would write that in your write-up. You can figure that out probably right here by using the numbers and what I've done in this attribute table. Well, there you have a bonus section, as it is, to help you get through this step. Right now it's the major step number 7 in Lab 8, which ends on page 16 of 18. I think you just gained something by watching this video. It will help you significantly.